In this video, we're going to be looking at this problem, longest absolute file path. So we're given a file system that stores both files and directories. Here's an example of that file system. So you have dir, then subdir1, file1.ext, subdir1, subdir2, subdir2, and file2.ext. And here's that in text form. So you'll see that everything is on a new line, and the level of the directory or file is the number of tab characters. So this is that as a string. /n and /t are the new line and tab characters. So keep in mind these are individual characters. Every file and directory has a unique absolute path in the file system, which is all the directory's names concatenated with slashes and then the file name. So the absolute path of file1.ext would be dir/subdir1/file1.ext. The absolute path of subdir2 would be dir/subdir2/subdir2. And all the directories in this problem, their names only consist of letters, digits, and or spaces, whereas the file names will always be in the form name.extension, like this. So obviously this is not true in real file systems in real life, but this problem is a simplification. Ultimately, the goal is that given one of these strings representing the file system, we want to return the longest absolute path to a file. Keep in mind, this is not the longest absolute path to a directory. We're only looking at files. Let's look at the examples. So for the first one, the longest absolute file path should be dir/subdir2/file.ext. So if you count the number of characters, including the slashes, it has length 20. For the second one, we have two files, file1.ext and file2.ext. But file2.ext obviously has the longest absolute file path, which is dir/subdir2/subsubdir2/file2.ext. And this has length 32. And then for the last one, so this kind of represents the kinds of edge cases where the file system only has directories and no files, in which case we return 0. Okay, let's break this question down. From the string that's given, obviously the first thing that we want to do is split it by new lines. And then we would end up with something like this, where every directory or file is on its own new line, each preceded with tab characters. Now we can iterate through this file system, line by line, but how do we keep track of the current absolute path? Let's think about how we would iterate through this by hand. So first we're at dir, then we go to subdir1, then we go to file1.ext, and then when we go to subdir1, we have to remove file1.ext, and then add subdir1. And then when we go to subdir2, we have to remove these two items and then add subdir2, and then subdir2, and then file2.ext. At this point, it should be pretty clear that we are exactly describing a stack. As we move deeper into the directory structure, we push each subdirectory or file onto the stack, and as we move out of each subdirectory, we pop them from the stack. The question is, how many items do we pop? So let's look at the example of when we go from subdir1 to subdir2. So at subdir1, the stack will have 3 items, dir, subdir1, and subdir1. And at subdir2, we want to pop 2 items since we want to remove subdir1 and subdir1. So if you try some more examples, you'll see that you'll want to pop size of stack minus current level number of items from the stack, where level is just the depth of the current directory or file. It's essentially the number of tab characters preceding. Let's add this to the pseudocode. Let's initialize the stack. And then for each line, if we're going deeper into the directory structure, we're going to push the directory or file onto the stack. And then otherwise, we're going to pop, as we said, this number of items from the stack. Then if the line is a file, well, we're going to keep track of the current longest absolute file path. So this is a great start, but we actually come into a bit of a problem. The thing is that we only care about the length of the longest absolute file path, but right now in the stack, we're keeping track of the file path itself, so meaning the names of its directories and files. The issue is at this line, when we encounter a file, when we try to compute the length of its path, we have to traverse through the entire stack, summing up the lengths of each directory and then adding the additional lengths with the slashes. Let's try something slightly different. In the stack, instead of keeping track of the names of the directories or files, let's keep track of the current file path length so far. So let's see this in action, and this will probably become more clear. So one tidbit is we're going to initialize the stack with 0 to indicate that starting from the root of the file system, the length is 0. Let's also have a variable keeping track of the max length to a file so far. Once we get to dir, instead of pushing dir onto the stack, we push 3, since that's the current length. Once we get to subdir 1, we first take a peek at the stack to get the length so far, which is 3. Then do 3 plus the length of subdir 1, which is 3 plus 7, and then plus 1, since with every level we introduce a slash in the file path. So we push 3 plus 7 plus 1, which is 11. Once we get to file1.ext, we do the same thing. So we peek the stack, see that's 11, add the length of file1.ext, which is 9, then plus 1. So we're going to push 11 plus 9 plus 1, which equals 21. And since this is a file, we keep track of this length. So we update max to be 21. Once we get to subdir 1, well, we're going to have to pop from the stack, but this time we're going to pop size of stack minus current level minus 1. So the minus 1 is because we initially initialized the stack with 0. Then we push 11 plus the length of subdir 1, which is 10, then plus 1, which is 22 onto the stack. So then once we get to subdir 2, we pop 2 items from the stack, and then we push 3 plus the length of subdir 2, which is 7, plus 1, which is 11 onto the stack. Once we get to subdir 2, we push 11 plus the length of subdir 2, which is 10, plus 1, which is 22 onto the stack. Once we get to file2.ext, we push 22 plus length of file2.ext, which is 9, plus 1, which is 32 onto the stack. Since this is a file, we update max to be 32, and then finally we return max, which is 32, and that's the correct answer. Let's update our pseudocode a little bit. So we're going to initialize the stack with 0 here, and then instead of pushing the directory or file into the stack, let's instead push this value, stack.peek plus the length of directory or file plus 1 onto the stack. And then we're going to pop size of stack minus current level minus 1 items from the stack. And then if line is a file, we keep track of the current longest absolute file path. So this looks fine. Okay, great. So we have a working solution. Let's look at the time complexity. So we have a loop iterating through n lines. Pushing an item onto the stack is O1, popping is O1, but we're not popping one item. We're popping size of stack minus current level minus 1, which is essentially on the order of the number of levels, which can be arbitrarily deep. So in our worst case, we pop from an arbitrarily deep level to 0. So our time complexity is going to be O of n times L, where n is the number of lines and L is the maximum level depth. We use space with the stack, and the stack grows as we get deeper into the directory structure. In the worst case, the stack grows to the maximum level depth. So the space complexity is OL. Okay, now let's implement this in Java. Start off with a stack. Then we're going to initially push 0 onto the stack. Then we're going to also have a variable keeping track of the max length so far. And we're going to iterate through this input, but we're also going to split it by those new lines. Now the level is going to be the number of tabs. So one way we can compute it is do last index of the tab character and then plus 1. Then we're going to pop those items from the stack. It's going to be while levels less than stack.size minus 1, stack.pop. Now we're going to push the current length onto the stack. So as we said, the length is going to be, we're going to peek and take the current length minus the level plus 1. So we're going to do s.length minus level, because if you think about it, if we try to just push the length of the string, it's also going to include those tab characters. So we do need to subtract them from that calculation. And we're going to push that onto the stack. The way we're going to check if it's a file is that we're just going to check if the period exists in the string. That contains period. Then we know that it's a file, so now we're going to update the maximum length. And at this point, we're going to return the maximum length. Okay, let's submit this. Great, and you'll see that it passes. And that's how you solve this problem, longest absolute file path.